let's see what insert interval has for us. What the description of that is. You're given an array of non-overlapping intervals where intervals of I is equal to start of sub I, end sub I, represents the start and end of the ith interval, and intervals is sorted in ascending order by start sub I. Okay, you're also given an interval, new interval, start end, that represents the start and end of another interval. Insert new interval into intervals, such that intervals is still sorted in ascending order by start sub I, and intervals still does not have any overlapping intervals. Merge overlapping intervals if necessary. Return intervals after the insertion. All right. Oh, right. And the other thing I want to do is go into AltaSnips. There it is. And add an LC here. Right. And that way I can say LC. Okay, so what problem number is this? This is problem 57. All right. So it goes right here. Lib. There we go. So 0057. Insert interval. We try to be. Oh, there's a little noise from Mike. Oh, yeah. Unfortunately, my heater is running. It's cold here in the Northeast. And I got to figure out how to put a filter on there so it doesn't. There we go. So, yeah, I have to build it first. So it doesn't pick up the background noise. I got to learn how to do that. So we have this solution here. Copy, paste. Returns a vec, which means we can say vec new. And then we can write our test case. Come on. There we go. Test. So we're going to take this as the input. EX1. We're going to create a vec of vecs. So I guess we can just say this and then just put vec in the way. Yeah, as soon as the heat turns off, that noise will go away. Sorry about that. And then the actual result should be this. Oh, right. And we have to call the solution here. Solution insert. And we're going to add 2.5. And now we need to vec everything. There. So basically it's taking this 2.5 and it kind of overlaps with this 1.3, right? So it becomes a 1.5 interval followed by a 6.9 interval. So how do we do that? I guess what we can do is we'll start off by creating a result array, a result vec, and returning that. We can loop through each. I guess what we can do is find out where it starts, right? Because we can look at the end of each interval, and if it's less than the start of the interval we're inserting, then we can just add it, just push it directly on the result. What if we create an iterator? And we can say while let some iter, some range equals iter next if range of, now just to check, I think this is just a vec, yeah, vec I32, it's the inner vec, it's a start end range. So range of 1 is the end of the interval. If that's less than the start of the new interval, then we can just push range. Can we do that? No, we don't want that because that's got the reference on there, clone. Yeah, that's better. Like Vorsa says, comparing the end and ignoring to compare the start will not work. If, well, so let's say we had an interval of 1, 3, 5, 7, 9, 11, like that, and we're trying to insert 15, 18. So we know it has to go at the end. So what I'm doing is looking to see if range of 1, the end of this interval, is less than the start of the insert interval. Then we can just skip that one and move on. Right? If we have another one here, like 21, 23, yeah, then the end of this one is not less than the start. So now we found a place to insert, I think. The only thing is, now that I went through that, I realized that we're actually peeling this range off. This iterator has to remember the range and deal with it at this point. So instead of doing it this way, I think I have to say let found range is equal to loop, because I can return a value from a loop, and then say if let sum. If it doesn't, then we can break some range, right? And if we don't find anything, we can just return none. I must have messed up the indenting somewhere. Oh, here. Right, if you insert 0, 3, okay, so if we insert 0, 3, let's see. Right, so range of 1 is not less than new interval of 0, so we'd stop at that point. Oh, yeah. Oh, if this is 0, 3 and we're inserting 0, 3? Yeah, so we'd still stop, right? Because range of 1 is less than range of 0, new interval 0, not less than. So we'd break with that. So now we'd have this range. Let's see if we can at least see that. Let's do this. Println pushing range. And then we can say ended up found range. And of course this doesn't work because I forgot a semicolon. No? Oh, I need a semicolon here. Yeah. And then I need the pub struct solution. All right. So this has ended up with some 1, 3. Right? So it found the range that we need to merge with. This is kind of awkward. But let's, I guess, keep pushing forward and then we'll learn how to do it right. Oh, so now we either have a found range or a none, right? So if I say if let some range is equal to found range, then we have a range. If we have a none, then we're done. No, then we exhausted the list and we want to say result push new interval return result. Let next is equal to, can we just return range this way? I guess so. Wow, this is getting complicated, because now we have the range that we either want to merge with or not, and we have to loop on that and keep merging. Okay, there's got to be a better approach. There's got to be a better approach. What if we consider it? What if we consider this? That for any given point in the iteration, we're either going to be at the start, or we're either going to be before the section we want to insert, right? Or we're going to be merging, or we're going to be after. So let's do that like as a we can create different stages, right? Enum stage, before, merge, and after. Let's think of it this way. And that way, instead of using this iterator thing, let's delete all that. Delete all that. That was a waste of time. Let's see. Let's say for entry in intervals. We can determine what stage we're in by saying let stage is equal to if entry of 0, if the start of the entry that we're considering is greater than new interval's end, then if the start of the interval that we're looking at is bigger than the end of the new interval, let's call it stage before. Else, if the end of the interval is less than new interval, like that, we're in stage after. Otherwise, we're merging. And that way we can look at each one. Let's do debug. And we can take a look at each one. Println stage. Save. So we have a merge and then a before. Okay. And then we can let's do another test here. This is a more complicated test example 2 here, and take a look at what it comes up with. x2, assert eq, solution, insert, paste, comma, vecbang 48, and that's supposed to be equal to vecbang 12, vecbang 310, vecbang 1216. Okay. So we're saying that the interval starts off after. We have to do 3 merges, and then we're going to do a before. Right. And this does merge and then before. Okay. So I think we're detecting things correctly. We just have to figure out what to do for each stage. So match on the stage. If it's over in the before stage, that means we put the push the entry. I guess we can just do this. If it's stage after, that's the same thing. Oh, yeah, we want to get, oh, we want to merge, right? So we want, actually, okay, how about this? Let mot2 insert is equal to new interval clone. And then what we can do is create this. Whoops. I hit F1 by accident there. To insert. And then what we can do is, if we're hitting before we do that, we want to push what we're going to insert and then the entry. But we have multiples, so we need to actually have a flag. Okay. Let mut pushed equals false. So we can say if not pushed, then we're going to push it and set pushed to true. That way we only insert the merged. To insert is going to have everything merged together. If we're in the after stage, if our insert interval is after the interval we're looking at, then we can just say result.push entry. And then if we're in stage merge, we got to figure out how to merge the current interval, which is to insert, with the interval we're looking at, which is entry. So it's basically to insert of 0 is going to be if entry of 0 is less than to insert of 0, then we're going to take entry of, we're taking the min, right? Because then we say else to insert 0, whichever one's smaller. So we can just say to insert 0 is equal to insert 0 min entry of 0. And then to insert 1 is the same thing, except a max, whichever one's larger. Does that work? And then we could say println result. What did I do wrong here? Semi? Typo? Value borrowed here after move. Value moved here. Oh, it doesn't realize that we're not. Okay, yeah, there's no way for us to know that we're never going to go through this code path again. So I think we just have to clone this out. Yeah. Oh, so that worked actually for both tests, but maybe we can eliminate this whole stage thing, because it looks like all we have to do is do these checks here. Let's see if this works as a solution. I have to pull in this derived debug business, well, the enum stage business at least. Make this a little bit bigger. I zoomed in and now it doesn't fit. Okay, that's better. Oops. I double clicked over there and it pulled that up. Okay. Let's see if this works as a solution, and then maybe we can simplify it, because I think we can eliminate this whole stage business. Now that we have a solution, I thought we had a solution. We don't. Okay, let's fix that one. Test ex3. So we have an empty vecbang, an empty vector, and we're going to insert 5, 7. And we should expect bang 5, 7. And that's over here. No implementation for. Oh, do I have to do a double vec here? Oh, okay, I get it. The solution has to be in a double vec. Yeah, okay. So it came up with an empty array, and so we're missing a push. We're missing a push, right? We're missing that final So we can actually look, if pushed, if not pushed, then we're going to push the interval. Result.push to insert. And we don't have to clone it this time. Let me get rid of these printlns. We don't have to clone it only because we're not using it anymore after that. So let's try that. Yeah, Nagvorsa, you got it. That was my mistake. All right, so that solves the problem, but I think we can make it simpler, right? If we can just, instead of doing the stage business, let's get rid of the stage business and see if we can just insert these bits here. Right? We can put this here. Get rid of the stage before. A stage after is just result push entry. And then the merge stage is just those two lines. And get rid of that, and get rid of that. Reformat. All right, let's run the tests. All the tests pass. Okay, good. So I think this might be a better solution. I don't think it's going to run any faster, but it's shorter. Yeah, it's slower. Well, again, we can't check this unless we run it like 10 times and average the results. So. All right, that was a fun one. We finished that, and we finished insert interval. Okay, let's commit these changes. Oh, right, I keep forgetting about Clippy. Let's check with Clippy. Oh, Clippy has, right, an issue with this guy and an issue with this guy. We don't need to clone. Redundant clone. Okay, I'll go with that. And then implement queue using stacks. Well, let's first commit these changes. Git status, git add source, and git commit -m problem 57. Insert interval. Okay, now we'll edit this guy here. And what are we suggesting? Impl default for queue? New without default. I guess we could add that, right? Can you derive default? Yeah. Okay, and all the tests should still pass. Oop. A bin target must be available for cargo run. All right, tests, not runs. Yeah, okay. Yeah, let's do that. Git commit -am Clippy. Nice. Okay.